Welcome to Chapter 6, Section 3. We're now going to talk about elastic and inelastic collisions. We're going to identify these types of collisions, and we're going to identify when kinetic energy is conserved and when momentum is conserved when things collide. When things collide, there are three types of collisions. Okay, and they have slightly different characteristics, and we're going to talk about perfectly inelastic collisions, elastic collisions, and inelastic collisions. But before we look at them, I just want to look at these two words, elastic and inelastic. So in English, these words have to do with whether something will return to its shape. Anything that is elastic can bend and return to its original shape without being harmed. Things that are inelastic then means they're not elastic, so they will not return to their original shape. So knowing the definition of these words will help you remember the definitions of these types of collisions now. So inelastic collisions, what happens is two things collide, they run into each other, and they bounce off of each other or something, they're bent out of shape, and then they keep moving. So example here, I have this car that has ran into this tree, right? But we know they're not permanently stuck together. However, both the tree is missing chunks, right? Pieces have fallen out of it, and the car is now bent out of shape. It's not in its normal shape. So inelastic collisions, okay, things change shape. But they don't stick together. Another good example is this guy catching the egg, right? He catches it and he'll keep some of it, but the egg will clearly never be whole again. It has changed shape, and you can even see the little bits of egg that are shooting off. And so the whole thing is not stuck together. It does not become one mass. And that leads us to our next type of collision, which is a perfectly inelastic collision. So this is really a special case of inelastic collisions. And it's special because when two masses collide, so here in this picture we have one mass that's running into another, they collide and then they get stuck together. So they act as one mass. So something is still bent out of shape, it's still inelastic, so we still get that change of shape. Okay, but now they stick together. So they become one mass. Everyday examples of this might be somebody tackling. Okay, now we know that people don't become one thing, but if somebody runs and tackles somebody and he's picking them off the ground, right, and they're going to fly through the air, and while they're flying through the air, they are one mass. They're not flying through the air separately, they didn't bounce off of each other. Okay, another example is when an asteroid hits the Earth, right? That asteroid's mass adds to the mass of the Earth. It will never leave the Earth. And so the Earth and the asteroid now move as one mass. Our last type of collision now is elastic collisions. So elastic means the shape does not change. So no change of shape. Okay. And these ones are a little more difficult to find in real life because things often change shape. So common examples are playing pool, okay, like these here. These are called billiard balls, and you might want to remember that because you may see these words in the future because this is used for examples a lot. So those are billiard balls because the game is also called billiards. And those balls, they're very hard, so when they run into each other, they don't change shape. Okay, they just collide and then move off on their own. Another example is this kind of thing, and hopefully I'll have an example in class to show you, but this is called Newton's cradle. Okay, and these little metal balls, they don't change shapes either. Marbles, if they run into each other, have elastic collisions, and so on. And so let's look at each one of these now. So because We've already talked about conservation of momentum. You can see here, and I'm sorry this is kind of difficult to see, so I'm just going to write this in black. Yes, momentum is conserved in all of these cases, whether it's elastic, inelastic, or perfectly inelastic. So momentum can always be used to solve these equations. But if we wanted, it turns out that kinetic energy is also conserved, but only in elastic collisions. So remember, elastic collisions, there's no change of shape. So when things do change shape, like in inelastic and perfectly inelastic, that change of shape uses some of the kinetic energy, ends up doing some work. And so we can't say that kinetic energy is conserved. So kinetic energy is only conserved in elastic collisions. Also, I want to point out that most collisions in the world tend to be inelastic or perfectly inelastic. Other than billiard balls and marbles and things like that, there aren't a lot of elastic collisions because almost any time two things run into each other, it's going to even lose just some molecules or atoms off of it. Even with billiard balls, they're not quite perfectly elastic collisions, although they are very close approximates of it. So most collisions in the world are inelastic or perfectly inelastic. All right, that is the end of chapter 6. So we'll have a discussion in class, and let me know if you have any questions.